Okay, guys, good morning. Today we will be adding and subtracting rational expressions. Yesterday we learned how to multiply, divide, and simplify them. Now today we're going to be adding and subtracting rational expressions, and hopefully, bless you if we have enough time, get to complex fractions. If we don't have enough time to get to complex fractions, your homework will be valid up until the point that you start completing complex fractions. At that point, you can stop if we have not completed everything. Now, there's nothing really new here except that it's just a new style of adding fractions. But you're going to add fractions the same way. Okay, you're going to find the LCM. Then once you find the LCM, you convert everything so it can have the equal lowest common denominator. And then after you have the LCM, you just add the numerators or subtract the numerators, and you keep the same denominator. It's just like adding 3/5 plus 8/5. That's going to equal 11/5. You add or subtract the numerators, and you keep the same denominator. Now, to find the LCM, it's very simple. First thing you want to do is factor all of the expressions completely. They're going to give you a rational expression, so we already know what those look like. We're going to go ahead and simplify those as much as we can, and we're going to factor them out. Once we factor it out into its prime factors, we're going to go ahead and multiply those prime factors together, okay? And each raised to the greatest power that occurs in any of the expressions. Let me explain what that little last part meant. I don't know if you guys remember, but we did Mickey Mouse LCM a little bit ago. Remember when we did something like this? What's the least common multiple of, let's say, 4x cubed y squared, and let's say, whatever, 5x y to the fifth? Remember, the numbers are easy, right? The least common multiple here is 20. But does anyone remember the trick with the variables? The least common multiple for the variables belongs to the, very good. The least common multiple for the exponents belongs to the highest exponent, bless you. So in this particular case, it'd be x cubed and y to the fifth. So that's what this means, the whole greatest power thing here. Whenever you find the least common multiple of variables, okay, it always belongs to the highest exponent. All right, good job, guys. Does that make sense? Yeah? Okay. So then now we can go forward. Let me explain with a little example. This is all about examples today. Okay. I've got 12x squared y times x squared plus 2x plus 1 and 18xy cubed times x squared plus 5x plus 4. I want to find the least common multiple here. So the first thing I'm going to do is I'm going to factor out the trinomial. So this is going to give me 12x squared y times x plus 1, or basically x plus 1 squared. Is everyone with me so far? Yes? Okay, and then I also have 18xy cubed, and then I've got x plus 4 and x plus 1. Okay, so this is the procedure we're going to use, bless you. We're always going to factor every single expression completely, all the way. Does that make sense? We're completely factoring it. Now, we got to find the least common multiple. So let's just go step by step here. First, the numbers. What's the least common multiple between 12 and 18? No, least common multiple, not factor, sir. Multiples are always equal to or greater than the original number, and 36 is correct. Okay, what's the least common multiple of x squared and x? X squared, because remember, it always goes to the highest exponent. Think of it this way, it's opposite. Least common multiple means highest exponent. What's the least common multiple between y and y cubed? Y cubed, because you go to the highest exponent. And then, check this part out. How many x plus 1s do I have? And how many x plus 4s do I have? So you just multiply those together. So it'd be x plus 4 times x plus 1 squared. Now, just so you know where we're going with this. If that was my LCM, okay, what would I have to multiply to this to make it equal to that? Come on, guys.
Oh,
What would I have to multiply to this? 3. You need an x. You need a y squared. And an x plus 4 multiplied to that. Great. What would I need to do to this to get it? I'd multiply it by a 2. Come again, son? Oh, yeah, no, someone told me x and that was wrong. Wow. No one has my back here. No, I'm sorry. That was my bad. So, yes. How about here? What about the second one? I need to multiply a 2 to get it to 36. An x and one more x plus 1 because I only had 1 here. Does that make sense, guys? Because that's the hard part. What doesn't make sense? What part? Which part? Because I did a lot here, so what do you need me to redo? The green. Okay. Thank you. Okay. Do you see that this is my LCM, correct? What do I need to multiply to this to make it look like that? What do I have to multiply to 12 to make it look like 36, dog? A 3. What do I need to multiply to x squared to make it look like x squared? Nothing. What do I need to multiply to y to make it y cubed? What do I need to multiply to x plus 1 squared to make it look like x plus 4 times x plus 1 squared? Bam. That's what I'd have to multiply to that to make it equal. What would I have to multiply to this to make it equal that? No. A 2, because 2 times 18 is 36. 1x. Nothing on the y. How many x plus 1s do I have? How many do I need? So I need 1 more. Thank you for your honesty. Does that make sense, gentlemen? Like I said, this is the hard part. Yes. Because the common denominator, the least common multiple between 12 and 18 is 36. How did I get that? We got to go back in time, man. This is not good if you have to worry about how you got this, guys, with all due respect. 4 times 3, this is 2 times 2. 9 times 2, this is 3 times 3. So the LCM equals the GCF times the leftover products. The GCF here is a 3 and a 3 and a 2 and a 2, so the GCF is 6 times the leftover products of 6, which is 36. Or you could just know your multiplication tables. It's very important to know your times tables here, guys. Yes, sir. The LCM is this. This is my answer. All I wanted was the LCM. I'm not adding them together yet. Why did I do the other things? Because that's coming in the next step. And I'm trying to be a good teacher and explain things and where we're going with it, sir. Okay? So now, let's go ahead and actually let's just find the LCM. That's all I want right now. Just find the LCM. First of all, factor each of these. So this is x plus 2, and this is going to be x minus 3 and x plus 2. Does everyone see that? So what would my LCM be? 2 times x plus 2 times an x minus 3. Very good. Just for giggles, but what I have to multiply to this to make it look like the LCM? An x minus 3. Well, what I need to multiply to this to make it look like the LCM? A 2. You guys see where we're going with this? Okay. How about this bad boy down here? Okay. Don't let that stress you out. You're going to have some complicated stuff ahead of you. It's coming up in just a few minutes. Let's just factor like always. Thank you, son. X plus 4, x minus 1. Correct. Next. X plus 4, x minus 2. Correct. Next. X minus 2 squared. Okay. So, guys, pay attention. What's the LCM? You need to remember, you need all of the elements together in one. So I have an x plus 4 that I need in all of them. Yes. I need an x minus 1 in all of them. And I need 2 x minus 2s. Very good, son. Very good. Does that make sense, my brothers? The question was, why do I need 2x minus 2's? Because in the LCM, don't we always go to the highest exponent? There's one x minus 2 here, but there's 2 here, so I need 2. I always go to the highest exponent. Thank you very much, son. Does that make sense, what he asked? Guys? Okay. You sure you got that? Okay. So now, just out of curiosity, just for giggles, what do I need to multiply this to get the LCM on x minus 2 squared? What do I need to multiply to this to get the LCM? On x minus 1 and an x minus 2. And what do I need to multiply to this to get to the LCM? On x plus 4 and x minus 4. Is that making sense? X minus 1. Is that making sense? Sir? Yes, sir. Yeah, that's what we said. We said for the middle one that we would just have to multiply an x minus 1 and an x minus 2. Because we need 2 x minus 2's in total. Does that make sense, son? Thank you. May I continue, gentlemen? Okay, let's move on. Now, let's do it for real. Just what I would do, just watch me for 1 second. Okay, just watch me. This is x minus 1. X over x minus 1 plus. I'm going to go ahead and factor. This is going to become x minus 1 and x minus 2. Okay? So the first thing I do is factor everything. Second step, my LCM. My LCM is going to be x minus 1 times x minus 2. Now, let's go back in time real quick. If it was 2/5 plus 1/3, what's the common denominator here? Don't we ask, what, I got to multiply 3 to top and bottom, and I got to multiply 5 to top and bottom, and then I get 6 plus 5 over 15, and then I get 11/15ths, right? That whole process makes sense? Because we're doing the exact same thing now, okay? I promise you. Check it out. Check it out. You have this x over x minus 1. What do we have to multiply to this denominator to make it look like the LCM? That's why I was doing what I was doing before. Now, do you see why I was doing that, guys? Okay. So x minus 2 over x minus 2. And then plus, do I need to multiply anything to this denominator? No, because that already is complete. Will it always be like that? No. Sometimes you got to multiply it to everything. But did everyone just see what I did? Now it's easy. Now it's x squared minus 2x plus 2x minus 1 over x minus 1 times x minus 2. This simplifies into x squared minus 1 over x minus 1 times x minus 2, which simplifies to be x plus 1, x minus 1 over x minus 1 times x minus 2, which then we already have the skill of being able to cancel. So my final answer here will be x plus 1 over x minus 2. Now, take a look at that. Look at what I did there, and then copy it down, and I will give you time to copy it down. And if you have any questions while you're looking at this process, now would be the optimal time to ask, because it's going to get harder from here. So I just want the procedures to be really simple. Sir, thank you. Okay, you just confused me because you said 7 different things. The question should have been, is that the way you do it, Mr. Morrow? And the answer is yes. Because what you just told me what to do, I just did. Yes, I'll go over it again with you guys. You have to first factor out each expression. That's what I did right here. Then you find an LCM. That's what I did right here. Then I converted each rational expression to have the same denominator. That's what I did here. Then I went ahead and multiplied and simplified the numerator. That's what I did in this step. Then I factored and simplified the rational expression sum that I have. That's what I had here. And then I simplified, and that's what I did right there at the end. So factor, LCM, convert, add, and simplify. Yes, sir. Yes, the restrictions here would be x cannot equal 2. Not 1, but 2. Does that make sense, boys? Questions on this so far? As you can see, it's long, it's tedious, but it's easy. It's very easy. Sir, what would be the use of this in real life? That is a wonderful question. Passing this class. No. To be honest with you guys, this has a lot of actual uses, and we're going to see those uses when we start doing the word problems, which I know is your favorite part. All of these computational skills can be used in word problems. My friends, every chapter we've done, we've had a word problem section, haven't we? Yeah, I know, I'm intense, I know. So we're going to have real life uses. Example, a lot of area problems are done this way. And to be honest with you, and not sarcastic, you do got to pass this class. And this is going to prepare you for higher level mathematics. And this is also going to prepare you for the SAT and the ACT. So there are a lot of uses for it, sir. There are a lot of things, though, that computers do nowadays, and I don't want to fool you and make you think that, you have to do this by hand if you were an engineer. Computers do it for you, but why learn it by hand? Because you already have an estimate of what it should be. Okay? For example, when I'm at the store, I can estimate my sales tax, roughly. Okay? It's about 7%. So I know that for every 100, I'm going to pay about $7. So if I have a bill for $200 and I see $32 in tax, I know there's a problem. I may not know the exact amount, but I know that it's got to be a lot less than that. So that works a lot with this too. When you're doing real life engineering situations, you're going to get answers, and you have to have an estimate in your head already. You kind of got to know what you're talking about. You got to have a picture of what to anticipate. So thank you. Good question, sir. Okay. Let us continue then, please. Okay, let's do this. I'm going to factor, so I got x plus 1 over x minus 1. What am I doing with putting in equals there? Sorry. Excuse me. Plus a negative 2 over x times x minus 1. Okay, next step. What's the LCM? X times x minus 1. Thank you, gentlemen. Okay, next step. What do I need to multiply to this guy? An x over x. Do I need to multiply anything to here? No, not in this case. So this is going to be x squared plus x minus 2 over x times x minus 1. Factor. This is x plus 2, x minus 1 over x times x minus 1. Cancel out the x minus 1. And you got x plus 2 over x. And thank you. X cannot equal 0. Awesome. Does that make sense, guys? As you can see, like I said, this is not difficult. It's not difficult. Just takes time. Sir. No, because if I multiply, the question was, when you multiply x over x, can I do like an x over y? No, because you're going to change the whole entire value of the problem. What is the value of x divided by x? 1. So when I turned it into this, did I change the value or the appearance? The appearance. So that's a great question, but no. If you're going to convert something, my man, the only way you can keep equivalent fractions is by multiplying the same value, whether it be a variable or a number or a polynomial. The same value to the numerator and the denominator. Sir, thank you. Good question. So another one. It's a little bit more complicated now. Actually, that's still Mickey Mouse. Okay, let's do this. This is x over x plus 2, x minus 2, plus 1 over x plus 2. Then I check my LCM. Thank you, guys, which is x plus 2x minus 2. Now, do I need to multiply anything to this first rational expression? What do I need to multiply to the second one? An x minus 2 and an x minus 2. So I'm going to get x plus x minus 2 over x plus 2 times x minus 2. Add the numerators, keep the denominator. 2x minus 2 over x plus over x plus 2 x minus 2, which will equal 2 times x minus 1 over x plus 2 times x minus 2. Does that make sense? And x cannot equal 2 or negative 2. Does that make sense, guys, so far? Promise? Okay. Now we're going to do a couple more like this, and then I think we're going to be able to get up to complex fractions today. So that's great. Yeah, I know. We're going to get up to, but we're not going to be able to include complex today. May I continue then? Thank you, gentlemen. Okay. Let's do this. We've got x plus 2 over x times x minus 2 minus x plus 2 over 2 times x minus 2. Okay. What's my LCM, boys? Pay attention to it. Yes. Yes. 2x, x minus. Great, guys. Great job. Great job. What do I multiply this bad boy to get the same denominator? 2. So I got 2x plus 4. Everything is going to be over 2x, x minus 2 at this point. What do I need to multiply to this bad boy? An x. So that's going to be, please pay attention to this. See how this is a negative? So when you're multiplying an x, you're really multiplying by a negative x. So please distribute that negative, gentlemen. Negative x squared minus 2x. Great job. Now, the 2x and the negative 2x cancel, but I'm going to go ahead, so I am going to factor out a negative, and I'm going to have x squared minus 4 over 2x times x minus 2, which is going to be a negative x plus 2, x minus 2 over 2x times x minus 2. Cancel, cancel. My answer would be negative x plus 2 over 2x. And then x cannot equal 0. Does that make sense, guys? Okay, look. Your homework's going to be a little bit different than what I had anticipated, okay? I do apologize. I just don't have time to continue. So what you're going to do is this. This is your homework. Please pay attention. On page 539, your Edline homework is not valid, unfortunately. So on page 539, it's going to be numbers 1 through 21 all. And the 2-5, or whatever it is for the prep works. I think it's 2-5 or 2-6. So the prep works is valid, but the other is not. God bless you. Have a great day. Bye-bye.